Okay, for exercise number 6 on module 3, we will have two views, front and right side in full section, and our goal is to create a 3D model using SolidWorks. So let's begin the planning for this and see how is the best way to approach this. Apparently, this is the section we deal with the Revolve tool, and Revolve is the best probably approach in this case. And let's start SolidWorks, and also notice units. Units is important in the beginning. Make sure that you have a correct unit, and this one is the metric units, as you see in instruction mentioned, and also on the drawing sheet itself says dimensions are in millimeters. So we need to make sure that our unit set up to be metric system. Then we will work on this rough sketch to create this shape, which is the half of them, and we will use Revolve to generate the model. So, and right now my unit is showing mmgs, which is the metric unit. So I'm going to just begin recreating this again one more time. Let's go to new file and then start part and OK. And we will make sure that our units, again, notice that as soon as I switch them, shows IPS. I will change to mmgs. And then you go to sketch, make sure that you have create the plane, the work plane in this case. We decided that we go to right planes, and make sure is normal to right click and normal to that plane. And we start with the line tool. And I'm going to begin with the center line to establish axis of revolution or axis for Revolve tool. And that make sure that you use center line, not solid line, rather just center line. And then we switch back to the solid line to create our sketch. And again, when you're creating the sketch, don't be concerned about exact size at the beginning. Just create the shape that you want to create, that shape. And just the best you can. This is again rough sketch, and we will come back and add dimension, make it fully constrained. I'm doing only half of them. As you see, when you close, automatically gives you the face, and the shade indicate that you have already connected all the points, otherwise would not give you that shade. And we have smart dimension selected, and we're going to add, let's zoom in here, we can see much better, and then select the smart dimension, I'm going to start with the thickness, which is 12 millimeter. And then we start into adding some more basic dimensions. Height in this case is 55. And next one, I'm going to add overall dimension. To pick overall dimension, I will pick a point on the top line and the origin or the baseline here, and then add vertical dimensions of 100 millimeters. 100 millimeters for that one. And you notice I lost some relations here, and I will probably add some dimensions to that. But before I add dimension, I make sure that these two lines should be parallel. At the time I sketched, maybe I did not pay close attention to, and it didn't have any constraint. So we can add that under the relations. We go to the add relations, and then select the add relations and pick the two lines. And when you pick the two lines, we expect to show you one of the options. Make sure that if you did not select correctly, this time I did not, because I picked a point rather than a line. So I press escape key and try again. Another way to select those by holding the control and select two lines. While you're holding the control key, select two lines. And then, as you notice here, parallel is one of the options. And select parallel. Same thing maybe you want to do in other ones if you need to. Right, let's see, finish this one. Come back to add another dimension here. So again, this dimension I'm adding between these two lines must be parallel before I add those dimensions. Otherwise, it would give you the angular dimension. So let's select the smart dimension and pick two lines. And that is also 12. We continue adding more dimensions. Also, we have another one here showing on the top here, which is 30. And then I have another one horizontal dimension between these two. As you notice, as I move my cursor, it switches back to the align, but I want to have horizontal dimension of 75. We need to add one more dimension here, make it 12. That would be uniform thickness, and now it's fully defined and my sketch is done. This is the major part of your work actually. Once you have this one created, go ahead, switch to feature. Under the feature, you see that extrude and revolves are activated. So I will select revolve bus this time. And because it's only one profile and one axis, automatically I expect that would pick that for me. Otherwise, you could select yourself, but normally it does automatically for you because that's the only one. Accept them because the default is 360 degrees and it's going revolving around this axis, which is center line, and giving you, generating that model that you are looking for. So that is pretty much is done. And the next step is to add those slots and holes. Let's go select that face and then add those two adjustable holes or slots. Under the sketch, as you saw on the previous one, we can select the slots, straight one. This one would be fine. And then start drawing some location approximately. And then repeat this one, another one underneath. Add in the smart dimension. Location for this one is given from the center to center 12. I will add that one first from origin. That's 12. Another one, same for the bottom hole. That's 12 also. Oh, I picked the both center to center. That would be fine. 12 plus 12 would be 24. I can do that too. Or you can pick individually 12 by 12. Some mistake there. I'm going to undo this and see what happened there. Probably I will erase this dimension and make sure redimension this one. Something happened in the process. Pick the center to origin, 12, that's correct. And another center to origin. This probably be safest way to do. Oh, again, something is happening there. Repeated the same thing. Okay, we have origin to center, and I'm going to do another one. Probably I should have got out of the dimension and repeat this. Now it's correct. 12. Okay, then diameter of this is 12 also. I can pick the radius of 6, or I can add diameter by picking two lines. Also 12. So we have center to the center 12 and also diameter 12. So the same thing for this one. And that should complete this one, but it's still underdefined. The reason is underdefined because we have not defined spacing between each arc. Each arc here has spacing from center to center by adding the two smart dimension between two point, the two center point, which is given 30 millimeters. 30 millimeters there. and this is the same thing for this one. I can add some relations to saying these are lining up exactly, or add another dimension. I prefer to have relations most of the time. I'm going to, this time I hold the control key and add, see if I can add relation between this center and this center, saying that they are vertical. And that is done. I have to do the same thing on this side. Advantage on doing this way rather than dimension for future change. Once you change this one, automatically that would follow. So you don't have to update both of them in case some future change required, which is normally happens in design process. Okay, here we go. And that's what we have. And it's still showing underdefined. The reason for that is how do I know the center of this adjustable hole aligns with this origin, which is not. That probably is the reason for. I defined the location how far up, but how about on the X direction? We don't have any restriction on that. So we will use, again, control, hold the control down and select these two, saying that on X direction also they are this, oops, I'm sorry, that was a mistake there. I shouldn't accept that one. That was incorrect. So I'm going to have relationship between this one and this one, saying that these are lining up. So I did not pick the right tool there. So I'm going to hold the control. This one, I'm picking the vertical relations rather than horizontal because that's what I want to do. Now it's fully defined. Apparently the top one is correct. The bottom one was off. Okay, so that is something that you always watch for, sketch to be fully defined. Next is going to be extrude cut option to remove the material, and both of them, and going through all. So that is created. Our last step is going to creating those small holes, which shows M8. This is the one that we are trying to create next. So far, we have done these two slots. We have created this half of this and revolved. We have the model, and we are going to create this holes, which there are 8 of them, as you see, 8x. And M8 is the size. That's the metric designation for this one is nominal size is 8, and 1 is the thread, I believe is the threaded hole. So you have that designation for a metric, and 21 mm deep. So that means doesn't go all the way through. This hole doesn't go all the way through. So let's go ahead, select the hole that has this specification. So let's find that. Selecting the hole wizard, accept that, and we need to make sure that we are in the right units first. This is standard NC, which is not what we need. We need to have ISO unit, metric, and then diameter of 8, and type of the hole. This one is going to be threaded hole. Hoping that's the correct one. And the bottom tapped hole. M1, 2, that's not the right size. M8 by 1, that's automatically is listed there. M8, 1. And the depth. The depth is specified 21 according to our handout sheet. That is the one we have. Double check that, make sure that I'm not missing that. 21 mm deep and 8.1, which we have already selected. So let's go to select 21. Let me see if I have listed here. Probably is not listed. 20. Okay, I have to type this one. 21. Show custom. Oh, that's not the correct one. That was end condition. You have to go to blind, and we're going to go 21. The top one, it's fine. We need to change that one. Restore default value. And okay, so the one that we're going to change, actually the 7 is default. That size, not the end definition, is the one changed to 21 millimeter, which as you see, I have selected here. By selecting the blind, gives you that chance to select. So now I need to locate my hole, zoom in this area, and position this one here somewhere. Okay. Okay, now I need to have relations of that in reference to the center. Let me go back to my view here a little bit clearly. Okay, so what information do we have for that? Let's just look. So this we know is lining up exactly here, and there is a center line here which we should have assumed. It looks like is the assumption that we have to make. Is perfectly in the middle, as you see here. They should have had dimension for this, what we call bolt circle, but it's not showing the dimension. So, but we know for sure this is exactly should be in the middle, equal distance. So we know the dimension on this one was 100. So if I go to this one 12, so that would be 6 between, right? 6 between here to here. So if I do the 6 less than 100, would be 94 radius. So if I add 94 dimension, that would be perfectly in the middle and also aligned with this center. So just something to be more accurate there. And let's go to that. So by adding the smart dimension between this point and this point, I can, let me see if I can finish this one here. I'm going to have back to the sketch, smart dimension, back to, I have to do that one before I edit the feature one more time. And I need to add that position, smart dimension between this one and this one to be, what did we say was 94, because we subtracted 6 from 100. See, this was 100 radius here, so 6 down would be 94. 94 dimension there. And now another relation, I need to have this one perfectly on center to center. For that, maybe I can have, see if I can have a relation. Let me just finish the sketch part and then finish the dimension part, and then come back, add relations between center to center, make him vertical relations. So we have two things we have to accomplish here. One is the size that going how far, 94. Another one is the relations that this one lines up with the origin. So now it should be fully defined. So we have that hole established now. As you see, the hole doesn't go all the way through. And you can tell all of this by changing your view too. Sometimes it's helpful to change to something that you can see clearly there. Okay, and that is the major part of it. I'm going to switch back to the shading mode and then switch back to front view. And now we have the hole established. Next, we're going to use the not to repeat this 8 times, rather we're going to use what we did in the last exercise using the linear and circular pattern. Using the circular pattern, selecting this feature that we did last hole. You can select them from here, but sometimes it's easier to extend this one. Click this arrow, and you see from the browser, the last thing I did was this hole, this one here, M8. So by this way, you can select for sure you have selected right one. See that appears here on the feature, and faces is selected already. So now the next question is, how do you want to rotate or use the pattern? Where is the center of the pattern? That you will be click on this direction area here, and then select one of these edges. Any of them would be fine, because your goal is to define the center of this piece, center point, which is the origin here. But you can pick any of the edge. It's going to pick that automatically. As you see, the preview shows us, because it already shows in 360 degrees, and I have 12 shows here because from my last exercise. So I'm going to change that one to 8. And also make sure that this equal spacing is selected. Maybe by default you will be having this one, and it's going only that, but make sure that you have selected equal spacing. And now divides that 360 degrees in 8 equal parts and gives you precise location, which would be all in 45 degrees. So let's finish that and then apply. And that completes your exercise. And make sure you save your work and submit as SolidWorks file, original file.